So, now it's me. First of all, thank you very much for having us here, SolidCAM team, and in particular Emil, to invite us to this very good show so far. My name is Lutz. I'm the Vice President of Europe for the company which is shown here. It's called, and I spell it correctly, Anisoprint. So that's what I've learned so far. Well, let's get started with this little analogy here. Skyscrapers. Millions of them are built on this planet, and we all ask ourselves, how does this work? Trillions of tons of concrete building upon each other? It doesn't work, because it only works because of this. But the secret of this steel reinforcement of skyscrapers is not only that they give stability, but they also distribute the forces internally in the structure to non-critical areas. So it's actually, this is a science in itself. Why did I show this? Well, because in a lot of industries we can actually see a kind of revolution when it comes to digital things overall. So talking about inventory, I mean, inventory is a huge cost factor in industry, and nowadays a lot of companies already went from physical to digital inventory, talking about production cost. I mean, you face it every day in your conversations with your clients. They all aim to have lower production costs with their machining. Manufacturing, I mean, we experienced it personally in the COVID crisis that we had the supply chain issues, and now more and more companies moving from offshore to local production. Logistics, from global to last mile. We want to avoid longer logistic cycles with our physical goods. And for instance, this is true for all the lifetime I spent in this industry, production development needs to be pretty fast. And demand planning, going from uncertain to predictable. Well, 3D printing does not solve. I'm not here to hyping 3D printing again, because I think we all experienced the last almost 40 years that it was hype, disillusion, hype, disillusion. We want to solve very, very specific problems, and that's why we are here. For your clients, I mean, yes, it could lower production cost. It could free up machinist talent to do the more precious work in the workshop. Improve profitability, have shorter product development cycles, faster changeover and product scaling, and reduce downtime of the machines. Now let's dig a little bit deeper in our technology, and you can visit it outside in the exhibition. So we are, first of all, an FDM printers, which is kind of pushing plastic through a nozzle and laying it down layer by layer. But our printers have a second nozzle besides the plastic nozzle, and this nozzle is shown here. So what they do actually is they transfer a reinforcing fiber, which in our case could be carbon fiber or basalt fiber, which is a natural product, through this nozzle, and on the side we push plastic also in it. So it is kind of a co-extrusion of plastic with continuous fiber. And we have a little cutter there, because from time to time you need to cut this fiber to lay down the next fiber routing. What it also does, we allow our customers to do so-called free fiber placement. So on the right side, for instance, you see a fiber placement which is specifically done in this part to catch up forces at certain points. So almost the same like the steel in the concrete, where it distributes the loads. We can do this. But even more, on the left side, you see that we can print internal lattice structures. So if you want to have an ultimate strong part with physical properties like aluminum or even steel, you should potentially start with this kind of lattice infill structure, because lattices also distribute forces equally in the part, in all directions, by the way. What we also can do with this is, and we currently applied for a research license for SolidWorks simulation, that we can place fibers actually at the point of need. I think this illustration shows it quite easily. Think about this part is held in the middle and pulled on the left and right side, and the fibers we laid down actually catch exactly those forces where the part gets pulled. The research license aims, in a sense, for getting into SolidWorks simulation, figure out the stress distribution in the part, and automatically give a fiber routing path into our slicing software. So that's what we aim for, and we just started this process. We also support an open material system. The only material which you are required to purchase from us are the fibers, the basalt fibers or the carbon fibers. With the plastic materials, you are absolutely free. I'm a firm believer that, I'm a plastics engineer, by the way, so I'm a firm believer that there is a reason why we have 100 types of plastics, because each and every plastic has very purposefully developed for a very specific reason. And not every plastic is good for a CNC shop, for instance. You know, hydrophobic materials which collect moisture and change properties and dimensions are not very good for a CNC shop when getting in touch with cutting fluid. It simply doesn't work. So in this case, you should choose a material which is non-hydrophobic, you know, and reinforce it with fibers, by the way. So you are free in choosing any kind of plastic which is within the specifications of this specific printer, and we have different printer models. We also support our software and materials, so it's kind of an ecosystem which we can give to your clients. Product lineup, I think I can skip this almost because Jörg already mentioned it. These are the desktop series printers. They usually kind of support your industry, your customers. I think these are the right fits for your customers in terms of producing tools, jigs, fixtures, jaws, soft jaws in a very strong way, and not a weak plastic way, but a very strong reinforced way, so they really do what they are expected to. Outside you can also see our new Composer Nova. Specialty here, it has 4 printheads and a printhead changer. So again, this allows for more diverse materials. This allows for solable supports, for instance, which you can then print and wash off. Or you can have different types of fibers with different print speeds, because thicker fiber prints faster than thinner fiber. The Promise 500, this is the really, really big machine, mostly found nowadays in R&D of larger organizations and universities. The temperature range and the heated chamber allows for printing high-tech plastics like PIC, PEC and Ultem together with fibers, which is kind of an exceptional way to do it. So aerospace, for instance, and transportation industry in general shows highly interested here. Software is our own development, so we can import STL files or we can import step files directly from your CAD environment and go and place the part and change the orientation, place the fibers and create a G-code file which we later use at our printers. Materials, as I said, we provide the carbons and so far and so on, but the other materials, the plastic material, you can buy from the free market. Like Polymaker is one of those filament producers where you can buy material from. Let's talk a little bit about applications and start with a kind of more a mechanical problem. Every mechanical engineer knows it. The so-called Kirsch problem. I mean, this hole reduces the geometry, and when you pull this part, actually it will break there. So what we did, actually, we prepared a print where we changed the routing of the fibers to absorb those specific forces and stresses in the part, which ends up in, when you do a test for this part, it doesn't break at the hole, but it breaks at a regular geometry. So again, carbon fiber used in a real professional way, I would say, can solve those problems. Also, here's another study from the University of Hamburg, which works in cooperation with Airbus. They think about placing fibers in 5-axis, which we also will support sooner or later together with 5-axis robots. Another interesting research and development, these are cube satellites. They are sent into space in thousands. Small satellites like this. And we can print the frames because weight, when you send something to space, is really of critical nature. Regular parts, like this rocker for a mountain bike, they withstand the forces. They replace steel parts, they replace aluminum parts. Again, another example from Formula Student. And here is one which is more from your industry. That's a tool holder, you know. And sometimes you need those tool holders to be very specific for specific or specialized tooling, and then you simply print them overnight. You know, pick them up next day, put them in, and it works. Another example, this is an example from packaging machinery, where we have end-of-arm tools which we use by robots or mechanics. You know, end-of-arm tooling is also a very good application. So whenever you need a gripper which holds something, or let's think about a vacuum gripper where you can actually print the vacuum channels, so you don't need to mill two halves and put them together. It's as simple as this. Another example here in turning machines, a soft jaw, 3D printed. It is strong enough to support this process. And the point is, why would you do these things on your CNC machine? So we are competing here with the status quo because we know that machine costs are the critical performance indicator in every CNC shop. The hourly cost of your CNC machine is the most important driver. So we need to think about how we can use this highly expensive machinery for the highly professional jobs. And these small jobs like doing tools, jigs and fixtures could be done by a 3D printer. Though there is immediate value for your clients, they see it. If you educate them, they see that this system is working. Well, and 3D printing is always considered to produce weak parts. No, we don't. Our parts are aluminum grade or steel grade quality in all dimensions. And I did a little calculation just, you know, for having a comparison in cost. You know, if you really calculate a machine with depreciation, power cost, maintenance, tooling and consumables, and to some extent even space, you come to a serious amount of money this machine costs per hour. The 3D printer, I mean, he has a shorter depreciation cycle, quite obviously, but still, it's so cheap in production that you immediately would consider, hey, why wouldn't I do things which could be printed, if they are strong enough, on a printer instead of a CNC machine, and use my CNC machine for the real valuable work. So I think your clients will certainly at least think about this possibility. And with this said, amortization is really quick. We have set up a partnership with SolidCAM Additive in Germany, and Jörg just mentioned this. So feel free to reach out to Jörg. He can supply you with information, with materials, with hardware and education to get in touch with your client. This said, I thank you very much and Dankeschön.